And the first thing I have up here on the board, we're doing the practice. Can you see it there?
Give me a moment.
Move
Write
my
it
stuff
down.
over
Yeah,
a little
let me
bit.
write that down.
I should have started doing it in my notes already, but I didn't. So that's okay. Why is there?
So when you're taking notes for the test for next week, just say, I'm going to need that picture. And it's not in the in the chapter 12 summary. You have to go back to, what page is that? Page 818 to find a picture of that. And you can just go to a copy machine and photocopy that page and bring it with you if you want for your notes, but you need to have that information. So the first question on the practice test on page 871, a college president wants to find out which courses are popular with the students in his college. So he surveys a sample of 30 students from the English department. Will these 30 students correspond to a simple random sample of the whole student body?
No.
No. And you guys know that from me looking and say, oh, look at that. 2/3 of my students are wearing tan sweaters today. So guess what that means? 2/3 of the girls on campus are wearing tan sweaters.
Oh my gosh.
Wow.
And when you check that out at lunch, what will you discover? No,
Not good to stay.
bad conclusion. You just can't make predictions on the whole student body from what happens in this class, can you? Question 2 and 3, skip it because it's not on the test. I mean, I know you know how to make graphs, but since it's not on the test, we've got enough other stuff to do where you just skip that. Question 4, during a certain week, the following maximum temperatures were recorded in a large eastern city. Find the mean of these temperatures. How do you find the mean?
You add them all up and divide them by
How many scores are there?
7.
6. So you add them all up and divide by 6.
Right?
So that's 4A. 4B, find the mode of the temperature readings. What's mode?
The one that occurs the most.
The one that there's the most. Which one is there the most of?
82.
Okay, there are 2 82s. So that's the mode. What's the third thing they want you to find? The median. What's the median?
The one in the middle.
And what's the one in the middle? Now what do I have to do to find the one in the middle?
You count them all and then split that in half.
Let's see, if I count them all, 1, 2, 3, 4, 5, 6, split them in half, and what?
There's 7.
What?
There's 7. The next one's on the next line.
So what's the median? Oh, there's 7. I'm sorry. Yeah.
Yeah.
Whoa, there's 7 of them. I can't believe I skipped that one. So there's 7. So you have 3 on each side. So what's the median?
Oh, they're not in order.
What's the median?
No, they have to be in order.
Yeah, that's
They
what I
what?
was thinking. They have to be in order.
Thank you very much. So that means I have to write them. Tell me what to write up here. What's the first one?
69,
And then what?
70, 71, 73, 78, 82, and 82.
82
Yeah.
again, or just once?
There's
Two
two
82s.
82s.
Put them both up there. And then what? 1, 2, 3, 4, 5, 6. That's it, huh?
Mm-hmm.
Okay. 1, 2, 3, 4, 5, 6, 7. So 3 on each side. The median would be 73. What if there were only 6 scores? Then what would be the median? It'd be right here, wouldn't it? Three on each side, and what would the median be?
Would you have to? What do you do then?
Yeah, what do you
we
do
talked
then?
about that.
What do you do then? It has to be right here in the
So
middle.
But there's two 82s,
So you
so.
add.
Okay, I changed it from having 7 to only having 6
Oh.
numbers.
You add the 2 in the middle and divide by 2.
Then you add these two, and 71 plus 73, and then divide by 2, and what do you get?
72.
72. So you find the average between these two middle numbers. And if this was 71 and this was 72, the median would be 71.5. Do you need to write yourself a note to remember that? Or will you just remember it? So many technicalities. And see why I want you to write notes for this? Because it's like we've done it, but now we forgot it. Now we have to remember it for a test. We're not going to remember it, so we write it down in our notes. All right, so we're done with 4. Now we go to 5. Find the range of the temperatures in problems 4. What's the range? We'll put this one back up here and mark the median as 73. 3 on each side. So now what's the range?
It's 82 minus 69.
It's what?
82 minus 69.
82 minus 69, which would be
60.
13.
Oh, 13.
13.
13. Have to do the math right, don't you, if you're going to get it. Find to 2 decimal places the standard deviation. Do you want to do it the hard way?
No, thank you.
No.
Where do we go? Oh, you can't see it.
Easycalculation.
Easycalculation.com. Erase all this. Get that off of there. Slide this over. So I've got my chart off to the edge. And let's see what we do here. We're at easycalculation.com, so now where do we go? I scroll down looking for what? Everyone see it on the screen? Standard deviation calculator. I click on it, and what do? Enter the numbers.
Mm-hmm.
Someone tell me what the numbers are.
78,
78, comma,
82,
82, comma,
82,
82, comma,
71,
71, comma,
69,
69, comma,
73,
73,
and 70.
and 70. Are we done?
Yes.
1, 2, 3, 4, 5, 6, 7. Calculate. And the standard deviation is what?
5 point something something something.
5 million.
Now, it's a multiple choice test. So here will be your choices. 5.59762, 5.59, 5.60.
What? How am I supposed to know which one?
What?
That's like all of the answers. Oh, but it says the 2 decimal places.
So would that be 60 then?
Yes.
That's tricky.
You see why? When you round, didn't it say to 2 decimal places?
Alright.
You look at this one, and if it's more 5 or more, you add 1 to this. What's 59 plus 1?
I just always get those wrong. Like I do the math right and then I pick the wrong one.
And then when you check your test, and the thing is, he'll put all 3 of those answers on there. This is not math is never easy multiple choice stuff. Good. So write yourself some notes on how you do this rounding thing. Number 6. A fair coin is tossed 256 times. We'll turn this off. Erase all this. A fair coin is tossed 256 times. And what does it say? It forms a normal distribution. Up in the corner, normal distribution. Do we all understand that this is a normal distribution? That's what this is called. So as soon as the problem says that it's an approximate normal distribution with a mean of 128, and a standard deviation of what? What's it say? Problem 6?
8.
8. So what's this number here? This number is 128. What's this one?
Did you say 128?
Did it say
Oh,
128?
it did. Sorry.
So this one's 120. What's this one?
128.
This is 128 minus 8. Minus 8. The standard deviation. So what's 120 minus 8? Minus 8. What's 112 minus 8?
104.
Everybody see where I'm getting my numbers? So now what do I say going the other way?
Plus 8.
Plus 8. So now I go plus 8, and I get what? 136, and then what? Can we all see that? Then what? Plus 8,
Yeah.
144, plus 8, what?
152.
1, what?
52.
52. So if you fill the chart out wrong, you're going to miss the problem. See? We have to take the information they gave us and create this chart. Now we can answer the question. 6A. Within what limits will be almost 100% confidence that the total number of heads in 256 tosses will lie? 100% confidence goes from here over to here. That's 100% confidence. So what are the 2 possibilities?
There are no 2 possible.
What?
Isn't it both?
Okay,
Which
I'm
one?
going to take
152
256 coins and I'm going to drop them on the floor. And I'm going to count the number of heads. And if it happens to fall perfectly, there'll be 128 heads. But there could be as many as
152.
or as few as.
104.
Everybody follow that? So now what's the question? What are the limits where almost 100% confidence that the total number of heads will lie? The limits are
152 to 104. Or 104 to 104.
from 104 to, the limits are 104 to 152. Now, does everybody understand what we're saying here? If I take 256 pennies and drop them on the floor, and then we count the number of heads, the average will be 128.
Okay.
But I can have as few as 104, and I'll have as many as 152. And if I did it 1,000 times, it would form a little curve like this.
I think I was confused because I'm like, well, it could happen 0 times, but this is saying like the average.
See, that's right. It could happen, but the mathematical probability of that is 0.
Very.
There you go. See, that, now that's what you're doing. See, wrap your head around this stuff and say, what does this mean? And if I did get less than 104 heads, then that means that some of my pennies are not fair pennies. They're flawed pennies. Okay, that's 6A. What's 6B? What's the probability that heads will occur fewer than 112 times? Here's 112. Fewer than 112 times.
What was the
Like
answer for the
0,
first
2,
one?
5.
Isn't that 0.025?
Between 152 and 104 is 100%.
So 0.025 is the probability, or 2.5% of the time.
Wait, fewer than. That always messes.
And I did this because I just thought it's easier to look at these numbers and percent signs, but you know how to go from that to percent. And if it messes with you, then just up above on your own chart, just go, this is 2.5%. This is 13.5%. See what you can do? This is 34%. See how you can take your own chart and just write whatever you need to on it to keep stuff straight. Because you don't walk around doing this all the time, so you don't have this stuff in your head. So you need to say, I need to have stuff written down to remind me what's going on. So do you see why when it said fewer than 112 times? If it would have said, what's the probability of getting heads more than 112 times? What would that have been? That would have been from 112 going this direction, and that would be what? If this is 2.5% and the whole thing's 100%, this would be 97.5%. Everybody follow that? I mean, it didn't say that, but you see how I'm going to change the question a little bit to see if you really are grasping what's going on, or if you're just using your brains for little calculators. Thinking about this math, thinking about it. And what's the probability that you'll have between 120 and 136?
Uh, 68.
68% of the time. You go, whoa, it's only 2.5% out here. Yeah, because it's this phenomena of a normal distribution That's why there's a big bump in the middle, because it gravitates toward the mean. Have you ever been to the Museum of Science and Industry in Chicago? Okay, do you remember that big pegboard with those steel balls?
Mm-hmm.
They have a big pegboard, huge thing on a wall. And the balls are collected into a tray. They're carried up, and then they're dropped from the top, right up here in the middle. You remember seeing that?
Kind of.
And as these little silver balls fall down, it's like there's probably I'm going to say 5,000 of them. And as these little balls drop down, most of them pile up in the middle, but guess what they form? They form the shape of a normal distribution. You go, that's just the way little silver balls fall when they're dropping through a maze. And when they talk about things are normally distributed, foot size is normally distributed. One size for women, another size for men. So people who sell shoes, they know that 68% of the shoes of the women's feet sizes are going to be within one standard deviation of the mean. That's why if you're one of the 2.5% who have a little tiny foot, or who has a great big foot, you can't find shoes because they don't make that many of them, because they're making them for the people in the middle. All right. Number 7. A normal distribution consists of 1,000 scores. Okay, so now we have 1,000 scores. And what does it say about it?
With a mean of 100 and a standard deviation.
So you see what happens? This is 100. And then what's this? What's the standard deviation?
20,
So what's this?
80,
And then?
60,
And then?
40,
There you go. And going the other way?
120,
And?
140,
And?
160.
There you go. You see how every time you work one of these, you have to have one of these little empty charts? Because I can't answer the question until I have this information on my normal curve. And I'm not going to put it up here on this one because this is the one I'm using for a reference. So you're going to make another one. So just bring a little sheet of paper with some empty ones on them so you can fill them in. Now, watch what 7a says. How many scores are above 140? Here's 140. How many scores are above 140?
0.025.
Now, 0.025. How many would be, how many of these 1,000? 0.025 times 1,000. See how it's 2.5%, but 2.5% of how many you had to start with. And what's 0.025 times 1,000?
25.
25? And you see on the answer key, he'll have 25, and then he'll have 250, and he'll have and then he will have 2.5. Why will he do that? Because he's trying to catch you. They didn't ask what percent would be above 140. The percent is 0.025, or the probability of having a score is 0.025. But how many? The how many question means I have to take that times the 1,000 that I started with. That's why you need to write that number down, how many scores you had to start with. 7b, how many scores are below 80? So now what do I take times 1,000?
So you add 0.135.
0.135. plus 0.025, 0.16. What's 0.16 times 1,000?
160.
160. All right, now we're ready for 7C. What does 7C say? How many scores are between 60 and 80? And what would that be? What do I take times 1,000 for the how many?
20?
One
No.
point 135.
1.135.
See? I'm
Yeah,
putting
I
that,
see
I have
that,
to
yeah.
use that number up there. 0.135. And what does that come out to be?
135.
135. And will on the test he have 20 as one of the choices?
Probably.
Sure he will, because he wants to catch you looking at standard deviations, not the percentages. And will he also have 0.135?
Mm-hmm.
Sure, or 13.5, because he's just going to try to catch you making a mistake. Number 8, testing program shows that the breaking points of fishing line made from a certain plastic fiber are normally distributed. See, as soon as they say that, you understand what I do? As soon as I see that word normally distributed, I go back to another one of these little empty charts, and what do I put on it for number 8? What's the mean?
10 pounds.
And what's the standard deviation?
1.
So this is 9, 8, 7. And what's this? 11, 12, 13. Everybody follow that?
Mm-hmm.
Now I've got my chart. Now I can answer the question. What's the probability that one of these lines has a breaking point of more than 10?
Isn't there a 50% chance probability?
And what is that? That's 50%, isn't it? Everybody see why it's 50%? So what's B? What's the probability that one of these lines has a breaking point of less than 8? Less than 8. And what would that be?
135.
0.025 or 2.5%, right?
Mm-hmm.
See, probability, remember probability means desired outcomes over total outcomes. The total outcomes would be 1,000 and the number desired is 25. 25 out of 1,000.
Yeah.
But if they said what percent is that, that would be 2.5%. See, when you look at this decimal, do you see how taking this decimal and turn it into a fraction helps you see the concept of probability?
Yeah.
Out of 1,000 samples, 25 of them will have a breaking point below 8.
Yeah.
Number 9, a multiple choice test taken by 1,000 students. So now, see, they didn't tell me how many lines I'm sounding, but they said I have 1,000 students. So I put that up here because I'm going to need that information, so I put it on my paper. And I erase this one. And what does number 9 say? The scores were normally distributed, being So I look for the mean, which is what?
50,
50. And what's the standard deviation?
5,
So this is
45, 40, and 35.
and this is
55, 60, and 65. Oh, the z-score.
and now I'm ready to go to work. Now I'm ready to look at the questions. Find the z-score corresponding to a score of 58. The z-score equals, do you remember that?
Yeah.
The score minus the mean divided by the standard deviation. You don't have that in your head, do you?
The z-score.
So you're going to write it in your notes that the z-score, so what's the score they just gave us? 58. So I go 58 minus what?
Um, 50.
Minus what?
50 divided
50
by 1.
Divided by?
1, right? Nope, 5, sorry.
What's the standard deviation? 5. Okay, so divided by 5. So that's 8 divided by 5 is 1.6. Agreed?
Yes.
So the z-score for a score of 58 is 1.6.
But what about that chart you gave us?
What?
You know that chart you gave us with the z-scores?
Yeah, okay. So now
Where
we're
does
going to
that
ask,
come in?
now we're going to add one more question. So watch what that said. A score of 58 is about right here. Agreed?
Yeah.
And that score is how far above the mean? 1.6 standard deviations. So what's the probability of getting that score? The chart?
So then you go to the 1.6 and then over to the 6.
Oh, no, is it 1.66 or 1.60?
1.60.
And so what's the number from the chart?
0.445.
0.445. So there's a 44% chance that a 58 will occur. Or out of 1,000 students, 48 of them, 44.5. Well, wait a minute. We got the z-score. So if this is 1.6 above, then that's 44. 34 plus 13 is 47, but it's not quite to 13. See that? So it's short. But if I said, how many students scored 58, or if I said above, then you understand? That would be from this, that would be the rest of it from here on up, which would be at 50% minus the 44.5. If I said how many scored 58 or less, then that would be this 44% plus this 54%. I mean, plus this 50%. So that would be 94.5%. And when I say how many of the 1,000 students who took the test. Now, they're not asking us that, are they? But see, you're saying, so what did we do with that stuff? See, once I know the z-score, I know how far it is from the mean, and I can use that with my table to determine the exact percentage that are going to be at that point. Okay. So, but all they want you to do here is just find the z-score. So, doing 62, you can do that in the same way, right? You just go 62 minus the mean divided by the standard deviation. So let's go on to the next problem. Number 10. Agnes scored 88 on a French test. So, on French, she had an 88. And what else does it say?
90 on a
90
psychology.
on a psychology test. And on psychology, she had a 90. The mean on French was 76. French, the mean was 76. And the standard deviation was what? You're not going to tell me. 18. For psychology, the mean was what? You're still not going to help me out. 80, and the standard deviation was 16. So, the z-score for psychology would be 90 minus 80 divided by 16. Agreed? The z-score for French would be 88 minus 76 divided by 18. Everybody follow that? See, they tell me the mean and the standard deviation so I can find the z-score for French and the z-score for psychology. Now, what's 90 minus 80 divided by 16? You're not going to tell me that either. You guys don't help me very much. 90 minus 80 is 10 divided by 16.
0.625.
Thank you. 0.625. See, she waits till I do it to tell me. But see, you guys, I'm going to keep saying that. You won't help me out, but it's okay. I like doing this stuff.
Just let you do it. You love it so much.
Yeah, we don't want to ruin your fun.
You don't want to kill my fun. Don't kill my joy. So what's 88 minus 76 divided by 18?
I think I got 0.0.
88 minus 76 divided by 18 equals 0.6666. Is that what we got? Okay, so here's my curve. Okay, so psychology is 0.625 above the mean, right? And French is 0.666 above the mean. So which score was her better score?
French?
Because
No. Wait.
because see, this one is only 0.62 above the mean. This one is 0.66 above the mean. So she scored higher in terms of the normal distribution in French than she did in psychology. You understand that? And you say, why is there a difference? Well, look at this. What was the mean score for psychology? 80, and she had a 90. The mean score here was 76. And so watch what you can do. I mean, just thinking about it. It was 80. She was 10 points above the mean. Here's 76, and she was 12 points above the mean. But that still doesn't tell you, because the standard deviations are different. The standard deviation here is 16. This one's 18. You understand how you have to do that z-score thing to find out exactly which score was better.
Mm-hmm.
Well, wasn't that fun? Now, you know what? Problem 11 is said, find the probability that a randomly selected student will have a score between 50 and 62. And you have to do that z-score thing for 50 and for 62. And then find those probabilities and find and subtract them. You find the z-score for 62 and then the z-score for 50, and then you subtract those two scores, and that tells you the probability. Remember how we were just doing one with that?
Yeah.
Except the one we did only had one number, but if you have two numbers, then you get the probability for both numbers and then say, okay, if the probability is in between these two, then I subtract those two probabilities to find out how much is in between them. Number 12, skip number 12. Number 13, skip number 13. Number 14, skip number 14. My goodness.
Whoever had this book before already knew that because they had X'd out.
Oh, really?
Number 15, the bar graph shows 2,000 sales. Shall I erase all this? See why you need lots of notes? There's just so many different things we're doing.
Mm-hmm.
Here's a bar graph that shows the sales for 2000. 2000 was 10. This is 2000. And what is this? What's the other one? 2004. 2004 is 15. Isn't that right? Is that what the picture shows?
Mm-hmm.
Now, what's the question? What's the percent of increase? Okay, we had an increase from 2000 to 2004, right?
Mm-hmm.
How much was the increase? 5. So the increase is 5.
Yep.
The percent of increase would be 5 over whatever this number was, 10. Because that's where we started with the 2000, and we had 10, and we increased 5. Do you follow that?
Mm-hmm.
So how much of an increase was there?
50%.
50%. Everybody see why? What's 5 over 10 if you change it to something over 100? 50 over 100?
It's still 50%.
So are you struggling with the percent of increase?
No, I just wasn't paying attention,
Oh,
so I don't know what we're talking
okay. Well, that's all right too. Number 16. When I upload the video, you can go watch it. 16. The typical family budget is as follows. Make a circle graph. Oh, do we all know where to go to make that graph?
Mm-hmm.
Do you have notes written? Do you have, as one of your favorites, create a pie chart at metachart.com? So just go to metachart.com and create a pie chart and then print it out. Or if you don't want to print it out, just send it to me as an email attachment. combonine@juno.com and say, here is my answer to question 16 on the practice test. Isn't that cute? Number 17, graph the 5 points given in the table below. Draw the best line you can between these points and estimate the value of y for x is 6. So they said, graph these points. And can you tell me what the points are? X is what? 1, 2, 3, 4. X is what? 1, 2, 3, 4, 5. And y goes from 2 to 10. So y is 2, 4, 6, 8, 10. And when x is 1, what's y? $10.2. 10.2. When x is 2, what's y? 7.6. 7.6. When x is 3, what's y? 5.8. 5.8. Oh, a little higher there. When x is 4, y is 4.4. 4.4, about right there. When it's 5, it's 2, down here at 2. And then I get my little ruler out. And I go, looks like my line is about like that. So when x is 6, it's about right here, which would be what? When x is 6, y would be, that would be like 6 and 1. Does that sound right? Find the equation for the best fit. What are we looking for here? EasyCalculation.com. What is that called? Linear regression calculator. EasyCalculation.com. Oh, I have to type it in again, don't I? Okay. Easy. C-A-L-C-U. EasyCalculation.com. And what am I looking for? Regression calculator. Is that what it is? Regression line calculator. Let's see what it tells me. There it is, linear regression calculator. See what I do? I click, are you seeing what I'm doing?
I can't.
Oh, you can't see. Tell me, turn it on. See, I just forget this stuff. Tell me to turn it on. You guys are just letting me ding around up here without seeing what I'm doing. Okay, do I need to back up and do it over?
No.
I went to easycalculation.com, see that up there? And then I typed in regression line calculate, and it popped up what I wanted, so I clicked on it, and it took me to all this stuff, and so I scroll down till I find the one from easycalculation.com. See that? I click on linear regression calculator, and then I come down here and I type in the x and y values. What are they again? X was 1, and what was y?
10.2.
10.2. 10.2. X was 2, and y was
7.6.
7.6. I'd add more. X is 3, and y is,
5.8.
that says 76. I didn't get the point in there, did I? 7.6. X is 3, and y is what?
5.8.
5.8. Add more. X is 4,
4.4.
and y is
4.4.
4.4. Add more. Come on. X is 5, and y is
2.0.
2.0. Is that it?
Yep.
Calculate. And there we go. The slope, the y-intercept, the regression equation. So now watch. So they've got all this stuff here for me. Then I go, what did they ask me to do? What's y when x is 6? So what do? I add a number. And what do I put in here?
6.
6. And hit calculate. And see if it gives me something.
Nope.
Nope. Okay, go down and look at your, what are your numbers again? Write those numbers down.
Which numbers do you want to?
The slope, the y-intercept. Oh, you could just write down the regression equation. Y equals 11.88 minus 1.96x. See how it's got those two numbers in the equation there? So now, since you've got that written down?
Mm-hmm.
So let's go back and say, we estimated it was 6 and what? Did we say 1?
Mm-hmm.
Let's put 1 in here. And then let's do calculate. Do we still get the same equation?
Not really.
So, we're not getting the same equation. So let's just go, what was the original equation?
I'm getting 0.12.
That's what I
Okay,
got.
what was the
Y.
equation
Y.
before?
Because
This-
it's basically
What was the other one? It was y
11.
equals what?
11.88 minus 1.96x.
And what? So we need to find y when x is what? 6. So we put a 6 in there. And then we take 1.96 times 6 equals 11.76. And then we take 11.88 and subtract 11.76.
0.12.
And we get y equals 0.12. Well, it's pretty obvious that my little picture wasn't very accurate, was it? See, based on the regression equation for these 5 bits of information, y should be right down here. See that? 6 and 0.12. You understand how I got that from using the regression equation?
Mm-hmm.
You see that?
Mhm.
Good. So what about page 874? The testing department of Circle Tire Company checks a random sample of 150 tires. $150 tires. And what did they find when they checked this random sample of 150 tires? Three tires are defective. Is that what they found?
Mm-hmm.
So what do they want to know? In a batch of 10,000 tires, 10,000 tires have how many defective? Well, out of 150, if it's three over 150 would equal question mark over 10,000, wouldn't it?
Mm-hmm.
So I just take 30,000 and divide by 150, and what do I get? 30,000? You're not going to tell me that one either.
Working on it. 200.
Divided by 150 equals 200. So 200 tires. So hopefully, when you're buying tires from Walmart, you don't get one of those defective 200. But if you do, and you drive away, and 100 miles down the road, the tire gets a bubble on it, you go right back to Walmart with your receipt and you say, you know, that tire you put on my car, it was one of the defective ones from the factory. The factory probably has 300 defective ones for every 10,000 tires they produce. So you need to take this defective one back, give me another one. And what's the probability of me getting 2 defective tires from the same store? You follow my thinking?
Mm-hmm.
What was it? Our microwave quit, and I had to go buy another one, and I got on the internet and found that the best price on a microwave was one that had a whole bunch of people said it's great, and then a number of people said it's a piece of junk. And I calculated the percentage, and I said, what's the probability of me getting a junk one? I mean, it's just obvious. The comments reflect the quality control at the factory. So I said, I'll go ahead and buy one because of the price, and I could buy it on sale somewhere. I think it was at Best Buy. And I thought, if I got a bad one, then it'll blow up on me, and okay, I got a bad one, but if I got a good one, it'll be good for a long time, and it's still working. Number 20, 50,000 high school students. So now I've got 50,000 students. Have you figured out my strategy for these problems? I just take the information a piece at a time and put it on my paper. 50,000 students. And what's it say about them? Took a test, and 4,000 got a rating of excellent. 4,000 excellent. In a sample of 100 of these, so if I had 100, how many would have had an excellent? Well, 4,000 over 50,000 is 4 over 50, so that would be what?
2 over 20.
8 over 100. Number 21. Which graph shows the best representation for the data? Which line looks like it's closest to a regression line? A, B, C, or D?
I'd say B.
Do we all say B? 22. Which kind of correlation would you expect from the indicated pairs? the value of your home and your annual income. There's three kinds of correlation: positive, negative, and no correlation.
That would be positive.
That would be positive. B, the number of hours of training and the number of minutes in which runners can do the mile.
No correlation. Oh, number of hours of training.
Positive.
The more you train,
Yeah.
the higher your hours of training, the what? Lower your minutes for running the race.
Oh.
Right?
Mm-hmm.
Wait, so what that?
It'd be negative.
Negative.
So that'd be negative.
Ah.
A person's shoe size and a person's salary.
No correlation.
No.
Unless,
I don't know.
I mean, I'm thinking there's no correlation unless you find out that, hey, all these people with large salaries, let's check out their shoe size and say, guess what? Those people who are making those big bucks, they're also the people with big feet. I don't know if that would work out, but generally I'd say there's no correlation. Number of children getting polio immunizations and the number of children getting polio.
Negative.
That'd be negative, wouldn't it? The more inoculations, the fewer polio cases. The coefficient of correlation for the regression line is about, now there's four choices. Okay, which kind of line is that? Positive, negative,
It's
or
a
no
negative
correlation?
one.
It's negative, right?
Uh-huh.
So I have two negatives to choose from. Negative 0.94 or negative 94.
Wouldn't it be 0.94?
Because correlation is always between -1 and 1. Remember that? Write that in your notes. Number 24.
Wait, what?
Correlation is always between -1 and 1. 24. Business intelligence software is one of the fastest growing segments. Find the line of best fit for this data. That's just doing this linear regression thing, isn't it?
Mm-hmm.
Did we do that on here? Linear regression line. Didn't we have something else we were using that for? Somehow it seems like we had one that made a graph and showed us all this cool stuff.
Oh, yesterday or Tuesday?
At that Alca something?
Calcula?
Yeah.
Mm-hmm.
Didn't I give you one called Alcula?
Yeah.
Use that Alcula thing for problems 24 and 25. Because it gives you both the linear regression and it does correlation coefficient, doesn't it? That was that Alcoa thing. Do I need to find it for you?
Yeah.
Where was it?
I just
Scatter plot generator.
Yeah, that's what.
That's what it's called. Scatter plot generator. SCatterplotgenerator. Scatter plot generator. And I'm going down to the one that says Alcoa on it, because that's the best one. Where did it go? Oh, there it is. It's the first one. Scatter plot generator, Alcoa. Enter the X and Y values. What are they? Two and 4. 2, 4. Enter. What's the next one? 3 and 4, 2. 3, comma, 4.2. What's the next one? 4 and 5. 4, comma, 5. Enter. And 5 and 5.8. 5, comma, 5.8. Enter. Submit the data. Oh, they want 5 or more values separated by commas. Well, what in the world? They're only going to give it, let me do it if I have 5? Because I have to have 5 values to use this thing? Boy, that's a sad state of affairs.
I made up a value.
Yeah, me too. I got pretty close.
Yeah.
So
I just made up another value. that
Let's just put
seemed to
another one in
track
here. What?
down.
Let's put 4 and 5
Can
in.
you turn on the projector, please?
4, comma 5. Let's put 4, comma 5 in again. See what happens? And there's the picture and a linear regression line. And a for 24, what's the answer to 24? Okay, what does it say here? Y equals 2.5. See what that did. 0.62. 0.62x plus 2.5. 8. Sure enough, just by taking one of those pairs in there and entering it twice, we're getting close enough to the answer. You follow that? When it only gave me 4, I just took an extra one and stuck it in there, 4 and 5, took the one there in the middle, 4 and 5, and just put it in twice. But look what it did. See, it only shows them up 4 times because it has that 4 and 5 in there twice. And that comes out to be the same answer as the textbook shows. And then in problem 24, find the correlation coefficient. We go back up here, and where we do the correlation coefficient, click on correlation coefficient, and it says it's 0.973. And the correlation coefficient with 4 at 0.973 would be what degree of accuracy? They've copied the chart from page 859 here on your practice test on page 875. So you say I had 4 scores and my is 0.973, so that's 95%, but not good enough to be 99%. So that's what it says, 95%, but not enough for 99%. You follow what happens? Well, I'm sorry I kept you over, but we'll make up for it by getting out early on the last day, won't we? Because all you do is come and correct your test. So,
Can
I
I?
need
Can I? Wow. Can I fix my test?
can you fix your test?
Yeah.
Sure.
You're so
And while you're fixing it, I'm going to go write this.
Well, I just have one more to do.
Okay.
I just-
I'm going to write this. What was that called? Scatter plot generator. Don't do that to me. SCATTER. Scatter plot. I'm just so much fun finding all this stuff. You know all the factoring you had to do in Math 241? Remember that when we had to factor trinomials?
Yeah.
Well, guess what I told the students they could do this time?
What'd you tell?
I showed them a place on the internet where they could go type in the A, B, and C,
Yeah.
and it factors it for them. Is that crazy?
Didn't have that.
Yeah. Why didn't we have that last semester? Scatter plot generator. They were all smiling just like you guys did when I gave you the ones for this class. Alcoa. ULA. Well, you ladies have a good day. Thank you for giving me such a fun start to my day.
Do you want our names on these?
Oh, yes, so I'll know how to pray. I could just pray for everybody with that, but if I have your name on it, then I can pray for you and